So in this video, we're going to talk about how to use linear functions to model data. So remember, you can write equations of lines given 2 points. So you're always going to start off by calculating the slope using this formula, and then you can plug in the slope in one of the points into point-slope form or slope-intercept form. So it doesn't matter which method you choose, either way you'll get the equation of the line, but this slide kind of highlights the steps for each process. Okay, so if you're going to plug into slope-intercept form, you're going to follow these steps. If you're going to plug into point-slope form, you're going to follow these steps on the right. So you can choose your favorite method and solve the problem however you would like to do so. So let's just look at an example, and I'm going to show you both ways of solving this problem. So we're going to write the equation of the line that passes through these points. So no matter what method we're using, the first step is always going to be to calculate the slope. So I'm going to call this first point x1, y1, and I'm going to call this second point x2, y2. So when I calculate the slope, I have m equals -10 minus 8 divided by -2 minus 4. So -10 minus 8 is -18, -2 minus 4 is -6, so -18 over -6 gives me an m of 3. So if I'm plugging into slope-intercept form, I'm just going to go to y equals mx plus b, and I'm going to pick one of my points. So I'm going to use this first point here, so I have 8 equals m, which is 3 times 4 plus b. Okay, so for your reference, I plugged into y equals mx plus b, and I just substituted the values of y, m, and x that I had. So this tells me that 8 equals 12 plus b, when I can now solve for b by subtracting 12 from both sides. So when I do that, I have 8 minus 12, which is -4, so I have -4 equals b. So the equation of the line, if I go back to y equals mx plus b, and I now plug in m equals 3, I have 3x, and then minus 4 for b. So y equals 3x minus 4 is the equation of this line. So let's suppose I didn't want to use slope-intercept form and I wanted to use point-slope form. So I'm going to use the value of m because the steps for calculating m are exactly the same. So I'm going to say m equals 3 from the formula, and then I'm just going to pick one of the points. I'm just going to use 4, 8 again, and so I'm going to call this now x1, y1. So I'm going to go to y minus y1 equals m times x minus x1, and I'm going to substitute what I have. So I have y minus 8 equals m, which is 3, times x minus x1, which is 4. So now I need to rearrange this equation into slope-intercept form. So I'm going to start off by distributing the 3. So that gives me 3x minus 3 times 4, which is 12. And I have y minus 8 over here. Now to get this into slope-intercept form, all I need to do is add 8 to both sides so that I get my y by itself. So I'm going to end up with y equals 3x minus 4. So you can see it doesn't matter how I do this problem, I end up with the same answer. So like I said before, you can just pick your favorite method and use it to figure out the equation of the line. So remember, we said that real-world data can be plotted on a scatter plot to determine whether there's a pattern in the data. So the scatter plot on the right illustrates a linear relationship between the number of years of education X and the median weekly income Y of workers. So we can estimate the line of fit by drawing it. You can see the line of fit is drawn here on the graph. And we're now going to figure out how to write the equation of this line. So remember, to write the equation of this line, we need to pick 2 points that are on the line. So I'm going to pick the 2 points that are circled in blue. So those points have the coordinates 12, 600. Okay, that's this first point right here. And the second point has the coordinates 20, 1600. Okay, so I'm going to need to start off with a slope formula. So I'm going to label this x1, y1. I'm going to label this x2, y2. So when I calculate slope, I have m equals y2, which is 1600, minus y1, which is 600, over x2, which is 20, minus x1, which is 12. So I have, now let's use my calculator, I have 1600 minus 600. So that is 1,000. So I have 1,000 over 20 minus 12, which is 8. So I have 1,000 over 8. So if I use my calculator to figure that out, 1,000 over 8 is 125. So my slope is m equals 125. So now I can use the slope and a point to figure out the equation in slope-intercept form. So I'm just going to use the point 12, 600, okay? So I have m equals 125, and I have that 0.12600, which is my x1, y1. And so if I plug in a slope-intercept form, remember I'm going to y equals mx plus b. So I have 600 equals 125 times x, which is 12, plus b. 125 times 12, let's use our calculator for that. That is 1500. So I have 600 equals 1500 plus b. And then now I'm going to subtract 1500 from both sides. And when I do that, I get 600 minus 1500, which is negative 900. So I have negative 900 equals b. So my equation is going to be y equals 125x minus 900. Okay, so that's the equation of the line that models this data. So now let's see what else it asks us to do in this problem. So it just says to write the equation, so we're good. Okay, so remember, lines of best fit are also called regression lines. And remember that we can use our calculator also to write lines of best fit. So let's look at this example. It says that a meteorologist collected the following data on the amount of snow in feet for different elevations. Find the equation of the line of best fit and use it to predict the amount of snow for an elevation of 4,500 feet. So I'm going to show you how to find the equation of the line of best fit first, because I know some of you use Desmos and I know some of you use the TIs. So let's look at this example, how you would do it on Desmos first. If you want to see how it's done on the TI, you can just skip ahead, and then I'll show you how to do it on the calculator also. Okay, so for Desmos, remember we need to click the plus sign, and we go down and click on table. So once we have our table, we're going to enter our table of values. So I'm just going to pause the video so you can go ahead and enter those tables in. Okay, so now that we have our table entered in here, remember to always just double check and make sure that the values are the same. Now we're going to go to row 2. So we're going to go to row 2 and tell Desmos to approximate a linear function. So we're going to type y1 and then use the squiggly that's to the left of your 1 key. Okay, y1 is approximately mx1 and then plus b. Okay, so down here in parameters, it's going to give us the values that we need to write the equation of this line. So it says m equals 0.0019, and then it says that b equals negative 3.27. So we're going to use those equations to write our, use those values to write our equation. Okay, so our equation is going to be y equals 0.0019. If you want, you can say 3, and then x, and then minus 3.27. Okay, so that's the equation of our line. So we'll talk about predicting the value when it's 4,500 after I show you how to do this on the calculator also. Okay, so if you prefer to use the calculator, here's how you would do it. Remember, you would go to Stat and then hit Enter on Edit, go up and then clear each column, right? So we cleared L2, now let's clear L1. So now I'm going to pause the video while you can go ahead and enter this table into L1 and L2. Okay, so now that we have all these values entered, remember we're going to click Stat and then arrow right to calculate. Choose option 4, which is linear regression. Keep hitting Enter until Calculate is highlighted and then click Enter again. And now it gives us the values of a and b. So we can plug a and b into our equation. And so remember, our equation was y equals mx plus b. So when we plug in, we get y equals 0.00193x minus 3.27. Okay, so we get the same equation. Doesn't matter if we used Desmos or our calculator. So the last part of this problem, it's going to be the same steps regardless of which method you use. So we have y equals 0.00193x minus 3.27. And so it says predict the amount when we have 4,500 feet. Okay, so remember that the elevation was the x value, right? That's what we did as our input value. So we're going to go ahead and plug in 4,500 for x. So we have 0.00193 times 4,500 and minus 3.27. So we can just use our calculator now to simplify this. So we do 0.00193 times 4,500. and then we're going to subtract 3.27. Okay, and then when we hit enter, it tells us 5.415. Okay, so we can say there's about 5.42 feet of snow at an elevation of 4,500 feet. Okay, so now you can pause the video and go ahead and try this example on your own. You can choose to do it using Desmos or your calculator. It's just up to you. Okay, so I chose to do this on Desmos. I just think it's a little bit easier sometimes to use Desmos since I'm on my computer. So I went ahead and entered the table, and you can see in row 2, I typed in y1 is approximately mx1 plus b. It gave me the values of the parameter that I can now use to write the equation of my line. So let's go ahead and do that. So we have y equals negative 1.83x, and then our value of b is going to be 3734. So we have negative 1.83x plus 3734. So we can now plug into this equation. So we want to predict the population with a landline in 2007. So we have y equals negative 1.83 times 2007 plus 3734. Okay, so if we do this on our calculator, we have negative 1.83 times 2007 plus 3734. And then when we hit enter, it tells us about 61 households have landlines. So it says, is it accurate to use this equation to estimate the percentage after 2020? We know that other things happened. So it's not just going to follow this relationship, because until 2010, remember, most people had landlines, but after that, with the advancement of cell phones, we have some other variables that are going to change this relationship. Okay, so no, it would not be appropriate. Okay, and then you could say the reason is something like other factors, like cell phones came in. And so that's why we can't just say that it followed this linear relationship. Okay. So remember that using your calculator, you can model data using linear regressions, and you can use these equations to predict future values.